All right, guys, we are going to be doing the energy and reactions lab. So what we're going to do is we are going to investigate two different reactions. We are going to watch the temperature. I'm using a temperature probe so that you can clearly see the temperature on the readout. We will take the temperature every 5 seconds until the temperature starts going in the other direction for about a minute. Okay, so you'll need a sheet of paper and you'll need to be taking your temperature readings every 5 seconds. And then I'll let you know when the temperature reverses and when to stop taking your measurements. So the first part is combining citric acid and baking soda. So I have already pre-weighed out 10 grams of baking soda. I'm going to add that to the calorimeter. Make sure I get it all. I've also pre-measured 30 mils of 2 molar citric acid. So as soon as I combine those two, I'm going to put on the lid and then I'm going to put the temperature probe through the opening, give it a stir, and then we will start our recordings. You can already hear and see the bubbles. We put the lid on, we put the temperature probe in. So start recordings, 17.3 every 5 seconds. Make sure you're getting recordings every 5 seconds. Notice the temperature still going down. Continue taking your readings every 5 seconds. You can pause the video if you need to. Still going down. It's going down slower. Continue taking every 5 seconds. Still going down. Still going down. Continue taking your readings. Still going down. It's going a lot slower now. Continue taking your readings. Continue taking your readings. Continue taking your readings. Okay, we don't have much movement now. Okay, we've started going back up. Okay, notice that we're going up now. So our reversal has happened. I started watching the clock when the reversal happened. We've got about 30 more seconds. All right, and that is 1 minute of a reversal. So that is the point at which you will stop collecting data. So our final temperature reading will be 6.9. Now, that is for part 1. One thing that I did forget to do is to take an initial temperature reading of the citric acid solution itself. So since I have the citric acid here, we'll go ahead and get the initial temperature since it was at room temperature, and this container has been sitting in the same room that the sample, it's the container that the sample came from. So we will get our initial temperature of just plain citric acid. Give it a second to get to the right point. All right, we're going to call it 19.7 for the initial temperature of the citric acid. So your initial temperature is 19.7. And then you've got your data from the calorimeter. Make sure you're writing down all of the data from the data logger during the reaction. There were definite indicators of a reaction. You heard and you hopefully could see, but definitely heard some bubbles going on during that time. All right, so now we're going to do our second reaction. Clean up just a little bit. All right, so same setup. Got a calorimeter. I have pre-measured 30 mils of 3 molar hydrochloric acid, and I have pre-measured 0.7 grams of magnesium. So let's go ahead and get our initial temperature of the hydrochloric. So the initial temperature looks to be 22.6. All right, so we're going to add the magnesium strips. And then as soon as I add the hydrochloric acid, we'll put the lid on and start our readings. Again, you can hear the bubbles. You can see the smoke. It's actually giving off a quite pungent odor. Okay, this one wants to tip. Make sure you've started taking your readings. Every 5 seconds. I'm going to move my hands because the lid's getting pretty hot. I'm having to keep it from tipping over. It's actually getting very, very warm. Take your readings every 5 seconds. There we go. It's getting a little bit hot for me. Take your readings every 5 seconds. Looks like we've already started to come down. All right, we're definitely coming down now. This was a much faster reaction. If you think about it, it's more concentrated. All right, and that is our 1 minute of reversed temperatures. So that is the end of your data collection. So now that you've got all of your data according to your lab directions, you will need to do your final and initial temperatures to determine the temperature change. But you're also going to be making a graph and doing a correction factor. So one of the things that you're going to be doing is finding where your graph levels off, either at the top or if it decreases at the bottom. And you're going to take that horizontal section and extend that line back towards the y-axis. We call that extrapolation. Okay, and you are determining the actual maximum temperature that was reached based on your extrapolation. So read the directions in your lab for how to do your correction factor, and then you will use this to determine the heat either absorbed or released by the water. And once we figure out the heat absorbed or released by the water, the opposite of that is the heat absorbed or released by the reaction, because the reaction is the system. The water that's in the solution is your surroundings. You'll then use that to determine the delta H of the reaction, which will be the same as the Q lost or gained by the reaction. And then ultimately we want to figure out what the molar heat of reaction is. So we will end up determining how many moles of reactants we used, of our limiting reactant that we used, and we divide the delta H we determined by the moles of the limiting reactant used. Excuse me. And so that's how you're going to work through this. The data collection was fairly simple. The calculations are a little heavy, so please make sure you're working through those very carefully.